Hello, my brilliant students, and welcome back. I know, exams are just around the corner, and ray optics can feel like a really big, difficult chapter, but please don't you worry. Your guide is here, and trust me, by the end of this, you'll feel so much more confident.
So, just take a deep breath. Forget all that tension. For the next few minutes, it's just you and me, and we are going to make this chapter super easy. Think of this as your final power revision before the exam. Chalo, let's get started.
Okay, first things first. Before we even think about mirrors or lenses, we have to talk about the most important thing in this whole chapter. I'm talking about the sign convention. Beta, if you get this right, I promise you, every single numerical problem will become a piece of cake.
This idea right here, the Cartesian sign convention, it's like the master key for this entire chapter. It's the secret code. Once you understand it, you can unlock any problem, doesn't matter if it's a mirror or a lens, so pay very close attention.
It's actually very simple. Rule number 1. Every single distance is measured from the center. For a mirror, we call it the pole. For a lens, we call it the optical center. Just think of it as the origin on a graph. And rule number 2 is even easier. The direction in which the light is traveling, that's our hero. It's always positive. Any distance we measure in the opposite direction, that's the villain, and it's negative. That's it.
Perfect. Now that we know our signs, let's use this new superpower on spherical mirrors. This is a 100% guaranteed topic for your exams, so let's make sure we can solve any question they throw at us.
And here it is, the famous mirror formula. You have to learn this by heart. 1 by v plus 1 by u equals 1 by f, where u is the object distance, v is the image distance, and f is the focal length. This is your magic mantra. Okay, time to solve a real exam-style question. This is exactly the kind of thing you'll see in your question paper. We have an object, we have a concave mirror, and we have the numbers. So let's use our golden rule of signs and our magic mantra to solve this.
Now watch carefully. The signs are everything. First, focal length f is half of the radius, so 15 by 2 is 7.5. But for a concave mirror, the focus is in front of it, against the direction of light, so f is minus 7.5 centimeters. The object is also in front, so u is minus 10. Now we just put these values with their signs into the formula. A little bit of calculation, and we get v equals minus 30. And what does that minus sign tell us? It tells us the image is on the same side as the object, which means it is real and inverted. See? Easy.
Fantastic. Mirrors are done. Now let's jump to lenses. You know, they're very similar, but there's one tiny little change, a small trap where so many students make a mistake, but not you, because we are going to see it right now.
Just look at the screen. The only difference between the mirror formula and the lens formula is that sign in the middle. Mirrors have a plus, lenses have a minus. Here's a little trick. Just think that lenses leave out the plus sign, so you use a minus instead. That's it.
And very quickly, let's talk about the power of a lens. This often comes as a 1 or 2 mark question. Power is just 1 divided by the focal length. But remember, the focal length must be in meters for this formula to work. The unit is diopter, which you might have seen on your glasses prescription.
Okay, now for one of my favorite topics, something truly magical, total internal reflection, or TIR. And this isn't just some boring theory, Beta. This is the real science behind why diamonds sparkle and how your internet works.
Now really, have you ever thought about it? What makes a diamond so sparkly? Or how do you get to watch all those YouTube shorts and Instagram reels on your phone without any buffering? Well, the answer to both those questions is this amazing concept, total internal reflection.
So here's how this magic works. 2 simple conditions. First, light must travel from a denser medium, like water or glass, to a rarer medium, like air. Second, the angle it hits the surface at must be greater than something called the critical angle. If both these things happen, poof! The light doesn't pass through at all. It reflects back completely, like a perfect mirror.
And this is exactly how your internet reaches you. Inside those optical fiber cables, tiny pulses of light carrying all the data just keep bouncing off the walls, undergoing total internal reflection again and again and again. They can travel for kilometers with almost no loss of signal. How amazing is that?
All right, let's finish up with a quick look at optical instruments. Now, for your exams, you don't need to worry about all the complex details. We'll just focus on what they do and the main formulas you need to solve the problems.
So, the 2 main ones are the microscope and the telescope. It's simple, really.
A microscope helps us see very, very tiny things that are close to us. And a telescope helps us see huge things, like planets and stars that are very, very far away. And here are the only two formulas you really need to know. Both use FO and FE. That's just focal length of the objective lens and the eyepiece. For the microscope, it's L by FO times D by FE. For the telescope, it's even simpler, just FO divided by FE. Just memorize these two, okay?
And that's it. We've reached the end. You have done so well. Now, for the final part, I'm going to give you a checklist. The absolute must-know things for your exam.
Quick, take a screenshot of this slide right now. These are the formulas you cannot go into the exam without knowing. We have the mirror and lens formulas, we have the magnification for both, don't forget that minus sign for the mirror, and we have power and the prism formula. This one slide is your key to all the numericals.
And last but not least, diagrams. You cannot get full marks in physics without neat diagrams. Please practice drawing these 4 types. A beautiful, well-labeled diagram, it can make the examiners so happy they'll give you full marks right away.
Now listen to me. You have worked so hard, Beta. You have revised everything. You know this stuff. So please, walk into that exam hall with your head held high. You are smart, you are prepared, and you are going to do wonderfully. All the very, very best from my side. You will rock it.